Thank you. This is sort of a topic that was suggested to us. I didn't know I was going to be here until the end of last week. Normally, Sarisha would be better qualified to do this, but I'll do my best. I just wanted to give a little perspective. You know, people have been doing these disaggregated OLTs before it was sexy. There's remote OLTs that get aggregated on a white box switch essentially, and then the virtualized management working with that, like for the cable industry, you take the DPoE and it'd be running up on a server somewhere. So there are folks deploying these kind of things already. So this is more about the not the conceptual ideas, not so new, it's more the details that are different. So I'm going to talk about not so much about product stuff. I'm going to talk mostly about what Nokia has contributed to ONOS. So that would be, or to our cords, that would be ONOS and Volta. And then I'm going to make some comments on some things we'd like to see in Volta 2.0. As long as I have a chance to talk about that. So one of the contributions that we made, it was showing up on the screen this morning, is this DHCP V6 Relay application. That's an ONOS application. It's primarily being done for a cable architecture. It's one where they don't use XOS, so they have to do some additional stuff beyond the basic DHCP relay. And I put the links in there. I won't go into the details, but you want to know some of them. It's down here, but it has some things like it figures out the routes and it will populate the quagga and the other tables. It works with the DHCP relay either in the pod or on the other side of a gateway. So it's got some extensions. They call them DHCP additional features that you would not get in a normal DHCP agent, relay agent. The other contribution that we made for ONOS for this cable use of cord is a multicast. This is not the same as the multicast you're probably more familiar with. On this particular one, the idea is that different serving areas have different channels available. And they use multicast to distribute the proper channels to the proper OLTs, basically, the proper places, the access nodes. Now, these access nodes, it could be OLTs or they could be other, cable, HFC DOCSIS boxes. Okay, so that's another contribution. This is actually changes that are sort of drivers and so on within ONOS. We've also done sort of the more conventional multicast thing. In the old days, IGMP was processed in the box in the OLT, so to be a join from the set-top box, be snooped in the ONT, processed in the OLT. On this case, it's being virtualized, get passed up through the gRPC to Volta, and then through a packet out up to the ONOS, and then the IGMP proxy that we contributed processes that. It decides if they're allowed to watch that channel. It figures out how to get that channel delivered. So that would involve setting up the path through flow modifications. So it'd be a flow modification. In this particular one, the flow modification, if you had open flow in the OLT, you could cause that to happen in the OLT. You could have the open flow to a top rack switch or some other place, but just illustrates it. And so that that's the R-cord contribution that we did there. One thing I'll just point out is that this is sort of like a drop-in replacement. It's a disaggregated OLT, but it fits into a conventional back-end network that goes into the BNG, has a video servers and so on behind it.
But the same IGMP proxy application works with, at least in the lab, right? It works with other OLT which doesn't have the
Yes.
And the multicast script in
Right.
the device. So.
Yeah, anywhere where you need to modify the path, the proxy would talk to those flow switches. Another contribution we made, and apparently everybody made a AAA one. I didn't realize that, but the same kind of idea here. The authentication protocols get sent through here to the OLT. They get popped up in the gRPC, and then through a packet out up to the ONOS, and then processed up there. It does the handshake with radius and so on, and then authenticates the customer and opens up the path. So that's the idea of that one. Then this is just a list. I'm not going to go through the list. You can, I assume they'll post the things. Anybody who cares, they can look at the list. But just some other odds and ends involving VOLTHA, ONOS, and so on. These are all, by the way, contributions that came from the fixed networks part of Nokia. There's been other parts that have contributed to, for instance, eCord, but that's not on this list. Okay, so the next part here, I'm going to talk about more detail about what's going on, what we're doing with Volta. So this is sort of the Volta, mid-year. One of the things that at that time, the netconf interface here, the northbound interface was rather limited. It could support OLTs, but it could not, you could not provision PONs or ONU. They were hard-coded. So a lot of the early stuff, there was hard-coded, when a device got attached, it would be detected, and then you'd have things attributed to it that were compiled there into the code. They were provisioned into the code. Ports would be fixed, names would be formulaic, and that sort of thing. I guess you had OLTs in this time frame that could support a single PON, not multiple PONs, which is, fine for a demo, but not for much more. There was these messages had to kind of get forwarded through the adapter, such as that. And then the OLT was, you couldn't provision lots of the attributes that you would in a normal, commercial product. So it's sort of rather incomplete. So like the gem ports and the allocation IDs were hard-coded. In a normal network, you would be able to assign those things because everybody's got a different architecture. They want to arrange things to their design. They want to manage the quality of service and so on. So there is. You've come a long ways in 6 months. I mean, you guys have done a lot. What's available now is much better than it was mid-year, I'm told. Nokia's been working on some parts of this, made some additions here lately. One of the things we do, so again, it used to only support the OLTs, but now you can configure PONs and ONUs. So that's an improvement. The configuration is based on that working text up there. The WT385 is the Broadband Forum Yang model document, basically. And that'll soon be a TR 385 because it's nearly completed. I suspect it'll be completed at their next meeting. So that's the Yang model. So that's supported. We contributed this XPON handler. It sort of receives configuration from the northbound there. It does a validation and make sure that it's, there's not overlapping names and things such of that nature, just to make sure it's a valid configuration. And if it's valid, then it populates the storage over here. It's stored in the database, and it assigns some addresses, the TC layer addresses, gem ports, and ALEC IDs, for instance. And then there's another module here that's the XPON agent. So what that does is it takes information out of the persistent here, the storage, and it distributes them to the ONU adapters and the OLT adapters. So that's how they get out there. And then we made some adjustments here on this adapter interface, sort of setting the stage so that in the future it'd be easier to separate that from the core. These adapters are really part of the core. They're not as portable, not as there's a dependency that you'd probably not want to have in the long run. So it's sort of preparation for moving them to like a gRPC type of interface to adapters in the future. I'm not going to go, this is basically his words for what I just said. I don't think I'll go through the slide in detail. But again, you can, if you're interested, read these slides when they get posted. And this is, you don't have to understand everything here. This is not an eye test, but I wanted to give an idea. This is the Yang model for an OLT. It's got stuff that you can't read, like channel pairs, channel groups, and so on. Most of this stuff is supported now. Most of these Yang model things are supported. The only parts that are not supported are the things you can read down here. These have to do with multicast and wavelength parameters. So these are things for multicast services and NG-PON2 type things. They're not available yet. The link table is not supported. This has to do with association of the ONUs with the OLT stuff, the mapping. So it'd be more flexible. So anyway, a good part of it is now supported. If you're interested, you can look at 385, where I stole this picture from, kind of understand the models. So what's missing, though, the stuff that I showed you was sort of in the blue box. Okay, these are like channel terminations, channel pairs, channel groups, so on. These were in the model, but there's nothing in there for the hardware configuration of the OLT or the hardware configuration of the ONT. And that's going to be necessary for if you really want to manage the box, turn on and off ports, so on, know enough about the box so you can manage it. So still work to be done, but it's not rocket science. It's just work. Okay, so since this is a simplified version of what I just showed before, one of the things that we view as an issue is that this is sort of it's a simplified, it's not really a netconf server. It's a simplified version that does some of the things you might see, but it doesn't do the validations. A normal netconf server would do the validations itself, make sure they're legitimate before it does anything. It would have a notion of data stores, so that you could have a working data store, and you could have a target, or I forgot, experimental data store, whatever the other name is, and that when you want to change configuration and you're ready, you switch to the other data store. If it doesn't work as intended, you can switch back to the old data store. It's quite robust, and that's the kind of stuff that's not in there. It doesn't have the basic netconf primitives like edit config, copy config. So it's not you probably wouldn't want to go into service with that deployment. It's fine for a demo, but it needs to be probably a real netconf server. And those are available open source. It's not like it's, you have to do a lot of work. You can get that. Okay. Now, some things like these northbound interfaces, they're generated by translations. In some cases, I understand it. Some protobuf would be translated into some kind of a message going up. So it's not in these protobuf can't capture the richness that you would have in a Yang model. They're more general. So if you wanted to do a more detailed configuration management, you'd want to use something probably better than the protobuf to represent things. Okay, this configuration is stored as protobuf and it's part of the core. So there's some dependencies on that. Might not be the best way going forward. So what we think, and there's ways to improve this, we think. One is to use a real Netcom server that does the authentications and the validations and has the data stores and all of that sort of stuff. That would be an improvement. These Netcom servers can generate from these models, they can generate the CLI, the REST interfaces, the Netconf interfaces. They're sort of built into this. You don't need to have this here. You don't need to translate from a protobuf to accomplish that. We think that these data stores would be better off being moved out and then using some kind of a, data center database technology. So you can get stuff that's, high availability, very fast, very scalable. Make use of those kind of data center data storage technologies. And we think that these adapters should not be in the core. They should plug into the core. Okay, and I think that'd make it easier to add new adapters going forward. Most of what you guys do, you use gRPC, for these interfaces. You may want to consider other interfaces as well. For instance, a Yang, you could use a Yang-based one. I mean, there are some that combine Yang and gRPC. I think OpenConfig actually is Yang over gRPC. So there's ways to combine both. So those are some suggestions that we'd like to make for Volta 2.0. And I wanted to just comment one. You've probably seen some of these pictures. This was the demo that was at the Broadband World Forum. So there's the edge core box here, the top rack switches, a couple servers. This blue thing, though, is the Nokia OLT. It's a little blue box. Two of these are our ONTs as well. Two of them are Broadcom ONTs. So that was the demo that was shown at Broadband World Forum. It was a working system, not just a mock-up. So it's a top-of-rack switch, multi-vendor, it's a cord pod, multi-vendor, multi-PONs, multi-OLTs. And the other reason I put this up there is because this is Sarisha Kora. I wanted her pick. She's leading the technical effort on from Nokia. And if you have questions, I would just refer to her because she understands what I just said. And this is our box. It's a 24-port XGS NG-PON 2 box. And it's got 6 uplinks. Each uplink could be up to 100 gigabit per second. It could be used in a couple ways. It could have a gRPC call up into Volta. That's what we demonstrated at the Broadband World Forum. It could also be running different software, so it could talk NetConf right up to a management system that was, a NetConf-based management system. So it supports both. It complies with we expect it to comply with the Broadband Forum TR385. So it's based on the standard Yang model for an OLT. And just you can't see under the hood, but it actually, like the KLX, there's some FPGAs. We chose FPGAs because we wanted control of our destiny, basically. We want something, we have FPGAs, they're known to work, they've been tested for a long time. That was the comfortable way for us to go. It's got some advantages in density and so on. So we chose that, and then it's got a Qumran sitting in the back there too. But we could use the traffic management stuff that's in the Qumran because we've got our own ways to talk to it, and we're able to run it that way. So that I believe that was it. So thank you. Do you have any questions? Cool.
So Rob, on that, can you go back to the improvement parts, right?
Oops,
Yeah.
that one?
That standard netcom server there, can that be a separate container? And, I wonder whether, that seems to controversy in some way, especially after a few talk this week. I think maybe some people don't want that interface, right? If you want to go a pure open flow related infrastructure architecture.
I suspect there is a way to do both. There is the typical way to do it that has been done in the past, where you're configuring everything, you're provisioning everything, you're using the serial numbers for the ONUs, you have interface level configuration that you can do through the netcom server, everything that is in 385 model. And you're specifying TCONs and gem ports and ALAC IDs, everything you're doing through the CMS, through this TR 385 model, going through the standard netcom server. You're right about that. And being able to do things through Volta. And then there is the more SDN dynamic way where you're not really configuring everything, but you're discovering everything. And everything that you discover, you can still expose via the netcom server, right? So it's more like a read model as opposed to a write model that you can go through netcom. So I suspect there is a way to do both, but we haven't spent enough time architecturally to see how both models are possible. But I think they can coexist.
Right.
And the choice is then up to the user of Volta to choose going down one way or going down the other.
Right. Because I think, I think that the argument exists since I started, experience with Volta is protobuf doesn't capture everything, right? So the translation is not one-to-one translation. So the protobuf representation of the problem-informed YAM model is not fully completed, or it takes a lot of time for that to be translated, or model has to be built from the YAM model to the protobuf. So I don't know. One thing to look at is that I think Volta, it doesn't need to be very bulky, right? I don't know whether have everything included and all the translation of the protobuf to reflect of the Broadcom broadband form model, whether that will make the Volta become very bulky or not. So that's something I'm wondering whether, that's why I thought maybe if that become a container itself, people decide whether they want to load it or not, right? So
I don't think it needs to be bulky. I mean, there are the DPU Yang model was defined a while ago, and there are basically Voltas for DPUs. They're called PMAs or PMAs. They exist. They manage DPUs from multiple vendors. So there's already some kind of a proof that you can, using Yang models, you can manage better than we've been able to do with OL ONTs in the past, but you're able to common management system for multiple vendors. DPU seems to be possible with NetConf Yang.
I mean, a service provider, right, especially a legacy service provider, that this is definitely more fit into our deployment model. But I just, at the same time, as a product owner or as a Volta community, I don't know whether other service provider will take this model or not. So that's
it's a good topic for discussion in the architecture meetings, actually.
Right.
And we get more service providers coming and giving that in.
You may, I don't know, don't take this wrong, but this is sort of a bubble, right? And or echo chamber. We're hearing some kind of same view. There are other operators that really want this NetConf Yang stuff. They're big believers in that. So, like for Nokia, we can't stop working on that way to do things also, right? It'd be nice if there was people kind of came together.
Yep.
Okay, so let's thank the speaker.